Hey guys, welcome to video 5 of Vehicle Electrical Systems. Today I'll be talking about batteries. First, what is a battery? A battery is a galvanic device which contains a charge differential across the two terminals. Batteries serve two main purposes. 1. Batteries act as an electrical energy storage device, which means that vehicle functions still can work without the engine running, and the vehicle can be started without having to turn the engine by hand. With old vehicle systems, you've seen these old crank handles on the very old vehicles. That's barring the engine over by hand. We can use starters, which use electricity to start vehicles, so that we don't have to do this manual, cumbersome labor anymore. 2. Batteries act as a voltage stabilizing device. When we discuss alternators in a future video, we will talk more about three-phase electricity, but until then, just understand this principle. When you have three separate phases, each offset from one another, and you have diodes that allow voltage to only go in one direction, you create this alternating current line of output to charge up batteries and run components. For running components, the battery acts as a voltage stabilizing device, so this line could be more like this. Without the battery, you'll have these like pulsations in the output from the alternator, and those pulsations can be seen when you have a fully drained vehicle. You'll see the lights start flashing and the accessories kind of gain maximum power, then lose power, gain power, then lose power. So, with a fully working battery, that battery acts as a capacitor, which means it stores charge and releases it to add a more even output. As a side note, when batteries have corrosion on the top, it's usually a result of gases being emitted during the recharging cycle of your battery coming from your alternator. Be careful charging frozen batteries as they can explode, and one sign of a frozen battery is the side casing will be a lot more expanded than it usually is. Normally, a battery will have a flat casing, and if you see a bulge within the center, like if you see this bulge like this, good chances that's a frozen battery. Now let's talk about 12-volt battery construction, specifically lead acid batteries. Lead acid batteries are made of two essential components: lead plates and an acid electrolyte solution. The lead plates consist of positive and negative plates. The positive plates are also called the anode plates, are formed of lead dioxide, which is lead and oxygen. And the negative plates, also called the cathode plates, are contained of sponge lead, which is just pure lead. Both the positive and negative plates are held in a grid. The grid is usually made of lead calcium, and all is contained in a polypropylene casing. As far as the acid electrolyte goes, it's composed of two main ingredients: sulfuric acid, which is usually 36% by mass, and water, which is usually 64% by mass, in a properly mixed battery and properly charged, to note. When you combine these two essential components, get yourself a single cell. A pair of positive and negative plates, or a series of positive and negative plates, form a cell. A fully charged 12-volt battery, each cell has 2.1 volts. This is important to note to figure out if there's a dead cell in your battery. In between these plates, as you can see by this little tiny gray line here, is a porous plate separator. They allow electrolyte to pass, but they stop the plates from touching. Vibrations, such as a loose battery, if your battery hold downs are not secure, can cause damage to the plates, or it can cause damage to this plate separator, which reduces the life of the battery and actually increases the chance of your battery shorting out, which is not a good thing. When it comes to combining plates, we must understand how voltage and amperage change. I discussed voltage and amperage in another video, but when we connect batteries in parallel, the voltage stays the same, but the amperage increases. And when batteries are connected in series, the voltage increases, but amperage stays the same. you can see that two 1.5 amp batteries put in series makes a 3-volt system. This also applies to battery cells. Most cells contain, instead of one positive plate, they contain 10 or more negative plates and positive plates connected in parallel. As they are connected in parallel, the 2.1 volt per cell battery that we talked about remains the same, but instead of it having the same amperage, the amperage increases. If it's 2.1 volts per cell, you may be wondering, why is it a 12-volt battery? Well, there's more than one cell per battery. In a normal 12-volt battery, we normally have 6 cells per battery, each at 2.1 volts. This makes a 12-volt battery, which is usually a 12.6-volt battery in reality. But we still call it a 12-volt battery. Looking at battery chemical reactions, it's important to note that in a fully charged battery, we have the maximum sulfuric acid concentration, which is H2SO4. So this is sulfuric acid. And we have the minimum amount of water concentration, which is H2O. As the battery starts discharging, the sulfate, the SO4, combines with the lead, which is Pb on the periodic table, to form lead sulfate, which is PbSO4. The hydrogen in the sulfuric acid concentration combines with oxygen, so the oxygen from this plate combines with hydrogen to produce H2O or water. As your battery goes from fully drained, the sulfuric acid decreases as it breaks down and goes into your lead plates, and the H2O concentration increases as the oxygen splits off from the lead plate and forms water, or H2O. So, in summary, your battery fully charged has the maximum sulfuric acid concentration with the minimum water concentration. And as it goes to fully drained, there's limited amounts of sulfuric acid concentration and maximum amounts of water concentration. Now, a question for you is, what happens to water in winter? Well, in winter, water freezes, and that's no different from a battery. So in winter, you can still freeze a fully charged battery, but it has to be really cold. The temperature needed to freeze a battery drastically increases when your battery is fully drained. Freezing can cause a swelling of the casing, and there's an extremely increased chance of battery damage. If you remember when we were talking about the dividers in between the two positive and negative plates, and when we talk about the plates themselves, those plates can crack, those plates can bend, those plates can break. And when we have a frozen medium inside our battery, not only does it reduce our ability to use that battery, but it drastically increases the chance of either shorting out or actually having that battery explode. When we are recharging batteries, the reverse reaction occurs. The reason a battery no longer provides voltage when drained is both plates are chemically the same. As you've seen over here, we have PbSO4 and we have PbSO4. And a fully drained battery, we have PbSO4 and we have PbSO4. So, as both plates are lead sulfate, there's no charge differential amongst the plates. As a side note, it is possible when you fully drain a battery to actually charge it backwards. That is, have the negative terminal turn into the positive terminal and the positive terminal turn into the negative terminal. I wouldn't recommend trying this as it is very dangerous. The last thing you want is for somebody to not know the difference, go off the casing, what is marked as the positive and the negative, and to hook that battery up backwards. Although I previously talked about parallel versus series connections, I want to describe the applications for different combinations of batteries. Automotive batteries are usually just a single battery. Sometimes automotive applications will have a second battery in parallel for starting. When we go to larger vehicles like semi-trucks, we'll often see multiple batteries, which usually it's 4 batteries, all connected in parallel. This keeps the same 12 volts across all batteries, but all the amperage gets combined. So if we have 4 batteries, each at 1,000 amps, that gives us 4,000 amps that we can use for starting, compared to just a single battery at 1,000 amps. In certain semi-trucks and in heavy-duty equipment, you'll probably see more 24-volt systems. And these 24-volt systems have two 12-volt batteries connected in series. This means they have the same amount of amperage, but their voltage is doubled. As a side note, sometimes you'll have and I'll get more into this into a later video if you guys want. Certain heavy duty equipment will be a 12-volt system, but only 24 volts for starting. They use what's called a series parallel switch. Basically, that allows for 24 volts strictly for starting, 12 volts for the rest of the system. Let's talk about some problems with batteries now. There's usually three main problems that batteries face in everyday use. Number one, batteries' internal resistance. When batteries drain, the resistance increases as pure water is not a good conductor of electricity. It's usually the minerals in non-purified water which enables the conductance of electricity. Temperature plays a role in which as temperature decreases, the electrolyte doesn't flow as well, and chemical reactions slow down. This causes an increased amount of resistance inside the battery. Sulfate buildup also plays a role, and is usually removed through charging the battery, but the problem with sulfate buildup is the lead material can actually break off from the plates, which removes the overall battery plate surface volume, which also increases resistance. When battery's internal resistance is too high, it causes the battery voltage to dip too low when starting. There's certain equipment that can test the internal resistance of batteries. I'll talk about that a little bit later. As for number two, low temperature starting. When it's cold, the engine oil is a lot thicker, which adds a huge load on the starter, and fuels are also more resistant to combustion when they are cold. Again, chemical reactions inside the battery slow down when they're cold, and batteries can also freeze. All this reduces the ability for a battery to function normally. Number three, battery high temperatures. They can also cause issues because as batteries get too hot, they tend to self-discharge. So that means that voltage will self-drain without actually having a flow through the battery. The sulfate coating on the plates themselves can crystallize. High temperatures can cause gassing of the electrolyte and evaporation of the water. This can also cause increased terminal corrosion. High temperatures can also cause internal plate corrosion, which leaves the possibility of internal short circuits. Let's talk about battery ratings, starting off with cold cranking amps. Cold cranking amps, also called CCAs, indicate the amount of current a battery can put out at negative 18 degrees Celsius or 0 degrees Fahrenheit, while still maintaining a voltage above 1.2 volts per cell or 7.2 volts in a 12-volt battery. Note that the CCAs increase when the batteries are put in parallel, same with the normal cranking amperage. And if a battery has a CCA rating of 500 amps, it means that battery can put out 500 amps for 30 seconds with more than 7.2 volts left over at a temperature of negative 18 degrees Celsius. The reason why the spec is set to 30 seconds is because starters can overheat after 30 seconds. Next, let's talk about reserve capacity. Reserve capacity refers to the number of minutes a battery can deliver 25 amps at 27 degrees Celsius or 80 degrees Fahrenheit and maintain a voltage above 1.75 volts per cell, which is 10.5 volts total. This is used when your alternator fails while your vehicle is running. Let's say it's going down the road. Your vehicle is running and your alternator fails. The reserve capacity tells you how long you can run that truck for before your battery completely dies and your vehicle shuts off. As to note, batteries in parallel also increase reserve capacity. This is usually why most times if you see multiple batteries, they'll be in parallel. Finally, BCI group. BCI group, I didn't really draw the chart for it because the chart's quite large and it's usually used by dealers. But BCI group stands for Battery Council International. It describes the battery size, the terminal layout, and the terminal type. Basically, dealers use this so they can order the right battery to fit into your vehicle without having to modify anything. Let's get into battery testing. There are many different ways to test a battery, depending on the type of battery, which we will talk about later. Starting off, let's talk about specific gravity. There are two different ways of testing specific gravity, with a hydrometer and with a refractometer. Specific gravity refers to the weight of the volume of any liquid compared with pure water. Water is being the reference, so it has a specific gravity of 1. Anything more than 1 is heavier than water, and anything less than 1 is lighter than water. Note that the batteries must be fully charged when testing specific gravity, as if you remember what we talked about previously, there's more water present in a drain battery, reducing the specific gravity number. That means there's less sulfuric acid concentration, so therefore sulfuric acid concentration plays less of a role in measuring specific gravity when the battery is drained. When a battery is fully charged, the heavier weight of the sulfuric acid concentration adds a lot more weight in the specific gravity reading. When using a hydrometer, which is basically like a turkey baster, it contains a float, this this thing in the center here, and that float has a line on it. You line the line on the turkey baster with the gradient markings on the side to measure the specific gravity. So as the specific gravity is higher, the float goes higher, and as the specific gravity is lower, the float drops. Sometimes hydrometers also have thermometers built into it, as temperature affects specific gravity. Pure sulfuric acid has a specific gravity of 1.835, but because electrolyte is not pure sulfuric acid and it is a mixture of sulfuric acid and water, you should see an actual specific gravity reading between 1.265 and 1.280 at 27 degrees Celsius or 80 degrees Fahrenheit. I can talk about how to adjust readings based off temperature in another video if you guys want me to. Be sure to let me know. Some batteries have built-in hydrometers as well, keep in mind, as over here. These are usually seen in low water loss batteries, as you cannot actually check individually in each cell. And also, most low water loss batteries do not contain filler caps. These hydrometers that they have built in only indicate the charge of a single cell. It only indicates if that exact battery cell is above a 65% charge. It'll show a green dot if it's above 65% charge. Lower than 65%, it'll show black because the black is basically an indication that you see that electrolyte solution. And if your battery is really low, where that electrolyte solution isn't really there, it's going to look clear. As far as refractometers go, they can be used also to check specific gravity of battery electrolyte, but they can also be used for testing coolant and DEF fluid specific gravity readings. Basically, what it looks like is a telescope with a glass lens that you put a drop of liquid on, and the height that that liquid goes indicates the specific gravity. It's actually pretty interesting how they work. Personally, I prefer refractometers over hydrometers. I have a multi-use refractometer which does have different readings on it for what levels you should see battery electrolyte, what levels you should see coolant, and what levels you should see DEF fluid at. But there are other testing tools you can use for all three of these. There's a few more testing tools I want to talk about, the conductance tester being one of them, and the carbon pile tester being the other. The carbon pile tester acts like a variable resistor based on the compression of carbon plates inside. The interesting thing about carbon is that carbon is an insulator with 4 valence electrons on the periodic table, but as the carbon plates are compressed, the surface area of those carbon plates increase, which lowers the resistance of those plates. Carbon pile testers often contain an ammeter and a voltmeter integrated into one unit. If you're using a carbon pile tester without this, you're not really knowing what you're testing. Sometimes you'll have to have your own ammeter and own voltmeter hooked up to the battery and a carbon pile tester separate. But when it's all integrated into one, it makes life so much easier. When you apply a load of half the cold cranking amps of the battery for 15 seconds, the battery voltage should not drop below 9.6 volts. With a conductance tester, it is the exact opposite of resistance. It applies a low AC signal voltage to the battery to see the battery's internal resistance. Conductance testers I don't care for as much. I would much rather prefer you guys use a carbon pile tester over a conductance tester. A lot of times conductance testers can put out false reports or false readings based off of so many different variables. A carbon pile tester is almost foolproof as long as you're using it right. The last discussion of this video is types of batteries. There are four main types of batteries in most vehicles. Starting off, we have the recombinant lead acid battery. Recombinant lead acid batteries, they're maintenance free, so the water doesn't have to get re-added. When these batteries discharge, the oxygen from the positive plate and the hydrogen from the negative plate form water without the use of oxygen and hydrogen gases being emitted from the battery. A lot of times when we talk about that corrosion buildup on the terminals, it's usually from the oxygen and hydrogen gases that are emitted that end up on those terminal plates, which cause the excess corrosion with batteries. That's why lead acid batteries that are recombinant have far less corrosion on the terminals. These batteries also contain safety valves in case the battery pressure gets too high, as they are a sealed unit, and they're designed to be more resistant to vibrations. Gel cell batteries are recombinant batteries with a gelatin type electrolyte to allow the battery to still function when it's not upright. This makes it great for off road use. Another plus side to gel cell is that they're deep cycle batteries, which means they can be drained to lower levels without damage. A downside is that they need a special charger that charges between 13.8 and 14.1 volts. They're a lot more sensitive to charging because of the gelatin electrolyte. Absorbed glass mat batteries, or AGM batteries, are recombinant batteries with the electrolyte absorbed into fiberglass mats instead of it flowing around as a liquid. This makes them great in cold weather and resistant to freezing. Plus, they have a relatively low internal resistance compared to previously stated batteries. Last is lithium ion batteries. I don't recommend you work with lithium ion batteries unless you are trained on them, as gases are extremely hazardous and the voltage is really high. There are two types of plates in a lithium ion battery. There's lithium manganese oxide and carbon plates. They don't use a standard electrolyte solution. Instead, they use an organic solvent as an electrolyte. Each cell in a lithium ion battery is 3.6 volts, and there's 48 cells per battery. 3.6 times 48 gives you 170 volts per battery, and usually there are two batteries put together in series for an electric vehicle, so that usually puts you at 340 volts. Major advantages to lithium ion batteries is that they charge faster, they last longer, and they're a lot lighter for the amount of energy you can store in them. But because they are very, very high voltage, I don't recommend you work with them. I don't recommend you do anything unless you have the proper training or procedures for them. 340 volts is very, very high compared to 12 volts. That being said, that's all I wanted to state for my battery basics. If you guys like this video, make sure to let me know. And thank you guys for watching.